Good morning. This video is actually for my nephew JT, but other people might find it interesting. One thing I wanted to do was include this with some video clips of me doing some tuning using a signal generator and an oscilloscope, my pocket oscilloscope. It's something that you take along anytime you do any kind of shows with anything like these guys here, and showing why, although this thing has impressive output, it could be a lot better. And the reason, this guy here, I can see right there, that is my current coil. It's my fourth coil. All of my coils in the past were smaller than this, and the primary coil that I'm using right now has a lot of miles on it. Miles as in years. I've used it with all of my, except my Slayer years ago. I built this primary a long time ago. I can't remember now exactly when, but over time my coils have gotten larger and larger. This guy here is, can't see behind me here. This is the largest one I've ever built. Of course, I named them all. This one I call Bernie. I bet you can't guess why I call it that. But this guy is just so big that although the output is impressive, you've seen the video clips of it, it could be a lot better. In Tesla coiling, a big part of what makes these have the impressive outputs that they do as far as the lightning bolts that they throw is maximum transfer of power. In order for that to happen, you have to have both the primary and the secondary resonating at the same frequency. And you adjust that by changing the taps on the primary. Back here. And basically, both of these items have a resonant frequency. In the case of Bernie over here, the secondary, it resonates at 789 kilohertz. Unfortunately, the primary from the innermost to the outermost turns resonates at 1700, which is 1.7 megahertz. So there is no way that I can get this primary to resonate at the same frequency as the secondary. It's impossible. What I will have to do is add some more turns to it in order to lower the frequency so that it is possible to do it. And a way that we do that is we use testing methods. In my case, I use what most coilers do. I hook up a signal generator and an oscilloscope, and I can see the peaks where they are resonant. So it works. You've seen it before. The output from this thing is pretty nice. It would be a whole lot nicer if the primary was in resonance with the secondary. I don't want to push it because as it is right now, Bernie here runs, this is a 1.1 kilowatt, that's 1100 watts. It's a 1.1 kilowatt coil. So running at the way that it does right now, out of resonance, if I tried to push any more through it, it's stressing the primary circuit badly. And it's because it's trying to run out of resonance. So, oh, by the way, I did finally find my actual toroid. It's over there. Finally. So at any rate, this is just a short clip. This is just the intro to it, but so that you can actually see me using my signal generator and the oscilloscope. It's just a little pocket oscilloscope that I'm able to take with me places, because anytime that you set this up for anyone, you always have to adjust it because resonances are going to change due to capacitance changes. These will change performance based on where you are, their surroundings, any objects that are close to them. So I will stop yakking here and let you see the quick little clip. I don't go into a whole lot on them, just showing you how I find the peaks in testing the resonance for the secondary and for the primary. Okay, secondary is resonant at 789 kilohertz. Okay, and here's one reason I don't get a little bit better power transfer than I do. I can get this thing to focus on my signal generator. I don't know if I can get maybe both in here. But on the oscilloscope right here, I am maxed at the frequency this primary is resonant at. And if I can get it to focus, doesn't look like it's going to. Well, this primary is resonant at 1700 kilohertz, which is way too high. The secondary is resonant at 789 kilohertz. So, I mean, it works. It would be working a whole lot better. There we go. Right there is where we're resonant right now. And I can adjust here just to fine tune it. See, now right now we're at 1100 kilohertz. If I turn it up, that's our peak. Because if I keep going, then we lose our peak. So yeah, right square at 1700. So what that tells me is we need our primary to be a lot bigger than it is.